In example 2, I've been asked to find the equation of my tangent at a given point to my curve. Now, if you take a look at the curve, you will notice that y could not be written explicitly as the subject of the formula. In other words, I'm definitely going to have to use implicit differentiation. The second thing you need to notice is that in the first term, on the left-hand side and on the right-hand side, you've got a product. In other words, you've got a function times by a function. And so we must remember that we're going to have to use the product rule in both of these terms. Just so that we remember, I'm going to already now write down that x is going to be my function f, and y cubed is going to be the function g. In the next product, x is going to be my function f, and y is going to be my function g. So differentiating the equation, I first use the product rule in the first term. The product rule says, find the derivative of f, times it by g. Add that answer to the derivative of g. The derivative of g is going to be 3y squared, but that was not in my desired variable, so I must remember to write dy by dx. Then I have to say to myself, still times that by the function f, which is x. The next term's an easy term, because it's only in the variable x, and I can just use the power rule. So the derivative of 3x squared is going to be 6x. Moving on to the right-hand side, and once again using my product rule, the derivative of f is 1, times that by g. Add that to the derivative of g, 1. As y was not my desired variable, I must write dy by dx, and times that by the function of f, which was x. The derivative of a constant is always 0. In my next step, I'm going to move all terms with the factor dy by dx to the left-hand side, and all the other terms to the other side. So on the left-hand side, I'm going to have 3x y squared all times by dy by dx, and then minus x all times by dy by dx. On the right-hand side, I'm going to have y, and then minus y cubed, and minus 6x. In my next step, I'm going to take dy by dx out as a highest common factor on the left-hand side. If I do this, then I'm left with a bracket factor of 3x y squared minus x. And that's still equal to y minus y cubed minus 6x. In my last step, all I need to do is divide both sides by the bracket factor of dy by dx. In other words, I'm going to have dy by dx is going to be equal to y minus y cubed minus 6x all over 3x y squared minus x. As I need to find the derivative at the exact point when x is minus 2 and y is 1, to find the derivative at that point, I take my derivative and I substitute every single y for a 1 and every single x for a minus 2. So I'm going to have that the derivative at the point minus 2, 1 is going to be 1 minus 1 cubed minus 6 times minus 2 all over 3 times by minus 2 times by 1 squared minus minus 2. And if you work this out on your calculator, you're going to get the gradient of your tangent. And the gradient of my tangent at this particular point is going to have a gradient of minus 3. We haven't quite finished answering our question, because the question asked for the gradient, the equation of the tangent. And the equation of a tangent is always given to me by the equation of a straight line. So now I have to substitute all my values into y minus y1 equals m x minus x1. So now I have the equation of my tangent is going to be y minus 1 is equal to minus 3 for my gradient, x minus minus 2. Distributing the minus 3 into the bracket on the right-hand side, I have that y minus 1 is minus 3x minus 6. And so finally, the equation of my tangent is given to me by minus 3x minus 5.